recap what you did last lecture was that I introduced to you your dot product. Can remember? Can the dot product be proven? Okay, it's a result or it's a process that cannot be proven. Okay, so please remember A dot B equals to magnitude A multiply magnitude B multiplied by your cosine theta. This is your dot product formula. Please remember it well. Next, I told you that if you want to find the angle, wrong. If you want to do your dot product numerically, can remember how to do it? Okay, look across horizontally. This thing multiply together, add to the second row, multiply together, add to the third row, add together, multiply together. Okay, this is your basic process when it comes to calculation of your dot product numerically. Then I told you that if you want to find the angle between your two vectors, what is the rule that you must follow? Both the arrows must point out from the same point, or the arrows must point towards the same point. Please stick to this rule. And then the formula that you actually use to find angle is actually your dot product. This A dot B equals to magnitude A, magnitude B, cosine theta. So cosine theta is A dot B divided by magnitude A, magnitude B. Okay, and of course I ran through this example, and then I ran through very quickly your directional cosine. So remember again, by definition, the directional cosine is the cosine of the angle that your vector makes with the three axes, the x-axis, y-axis, and the z-axis. Okay, so I know some of you actually are blurred. Wow, how does this formula come about? Okay, this formula is actually this formula. Cosine theta is equals to A dot B over magnitude A, magnitude B. So again, I also understand there's this issue. Can you tell me, yeah, this one is something new from last lecture. Can you tell me what is the vector that represents the x-axis? What is the vector that represents the x-axis? Okay, so you need to recall back from your chapter 1. What do I mean by a vector? A vector that represents the x-axis will be a vector that is parallel to the x-axis. Make sense? What is a vector that is parallel to the x-axis? Anyone? 1, 0, 0. Can I say? Is 1, 0, 0 parallel to the x-axis? Is 3, 0, 0 parallel to the x-axis? Is minus 20, 0, 0 parallel to the x-axis? So why did I choose to use 1, 0, 0? Easy, ma. I use a number that's smaller, it's easier to handle. Okay? So this was the gap that I need to fill for you from last lesson. So as I say, cosine alpha is the angle that your so-called your vector OP makes with the x-axis. So this 1, 0, 0 is actually the direction for your x-axis. Similarly, cosine beta is the angle that your vector makes with the y-axis. And then y-axis is 0, 1, 0. It's parallel to 0, 1, 0. Then of course for the z-axis, 0, 0, 1. Okay? So please write this down. Okay, this is the x-axis, y-axis, and fundamentally we are just activating this formula. Okay? Anything still not clear pertaining to your directional cosine? Okay, then of course, last lesson I also finish up your examples 3, by which you actually were to find the different various directional cosine. Okay, seriously, not to worry too much as far as this directional cosine is concerned. Okay, as I said, since the introduction of this into your current syllabus, we have not seen an A-level question pertaining to directional cosine because is rather trivial, and there isn't much application as far as this is concerned. Okay, so I seriously don't want to spend too much time on this. Okay, let's go to the next example, which is more important. Okay, can you please asterisk example 4? Okay, this is a classic example by which is a question that doesn't have any numbers. Okay, so when there's no numbers to handle a question, you need to rely on your properties. Remember, I asked you to highlight the 2 sections on the properties in your chapter 1 and of course the properties in your chapter 2. Okay, so this identity that I asked you to prove is magnitude u plus v square plus magnitude u minus v square equals to 2 magnitude u square plus 2 magnitude v square. Okay, so not to get too frightened over things like this, remember your secondary school skills. If I ask you to prove an identity or ask you to prove an expression, you either start from the left or you start from the right. So adopt the same approach. So let's start from the left first. The left you have is u plus v magnitude square. Okay, how does it equal to this? Okay, I'm actually activating a property already. Okay, can you please reference to the page on the properties? Okay, although I've written out on the right column, I want you to be familiar which property we're actually using. On page 13, 2.3 properties at the bottom. Okay, the properties pertaining to your dot product. Okay, so do you know which property did I use to get the first line? How does this thing come about? Which property am I using? Look at all the properties in your page 17. Can find out? Cannot find it. It's actually on your page. Okay? Page 14. You have a u dot u under your 2.4 remarks. U dot u is equals to mod u squared, magnitude u squared. Can see the box which I asked you to highlight previously? Okay, that is the property that we are activating here. U plus v mod square, magnitude square, is equals to u plus v dot u plus v. Can I find that property? Okay, that's it. You need to be familiar, or else you cannot do at all. What you do next is you actually activate more properties. Okay, this second set of properties that we should actually use is easier to accept because it's actually your distributive law. Okay, it's your result number 3 and result number 2. The first one is actually from your 2.4. So please add in. This important result comes from your 2.4. Okay, then what happens next is your distributive law. Okay, u dot with u. Be careful, it's dot. It's not multiply. So the dot must be observable, can be seen. Okay, make your dot clear. U dot u plus u dot v plus v dot u plus v dot v. Then what you see next in your second line is that u dot v, v dot u, based on your property and your result from your properties again, they are the same and interchangeable. U dot v is the same as v dot u. I can combine them to get 2 times of u dot v. Okay, that's your next property. Then what happens next is, what is u dot u? What is u dot u? By your properties. 2.4. Magnitude u squared. Okay, your 2.4 properties come in again. U dot u is magnitude u squared plus 2u dot v plus magnitude v squared. So far so good? So far so good? Okay, I think in your lecture notes there's some jumble up. The next section that should follow should be this. Okay, I think in your lecture notes the thing jump. So now can you please try on your own? What is u minus v squared? Follow the template you did for the first one. Can you actually give me the result for u minus v? Okay, you should be able to get magnitude u squared minus 2 times u dot v plus magnitude v squared. Then of course you can combine the two results together to show the right hand side. Because the 2 times of u dot v should subtract off. Okay, so while you're copying, I want you to please remember questions like this. If you actually don't remember the properties, you seriously cannot start a single line when it comes to a question like this. Okay, so that's the first thing. Second thing, there's no boundary as to what we can test you when it comes to questions like this. This is only one possibility. In your tutorial, you see many other possibilities. Sometimes they ask you to prove different stuff. So bear in mind, properties must be at your fingertips. Okay, in order to handle a question like this, we cannot possibly exhaust all the possible mutations when it comes to this kind of questions with known numbers. So it's very risky, very dangerous. Students hate this kind of question. You're going to encounter one of these in your upcoming CP1. Okay, one question will be without number, pure properties. Any questions so far? Any questions so far? Okay, before I move on to the next section, can I do a quick revision again? Can you accept that AB is equals to OB minus OA via your vectors addition? Can I accept? Can I also say that AB is equals to DB minus DA? Can I accept? Anybody cannot understand this? Can I? Okay, so you'll be relying on these two important knowledge, right? Subsequent part of the lecture. Okay, so what we have used so far, when it comes to dot product, let's do a quick recap again. Dot product, we use dot product to find angles, and specifically we have been using it for co-directional cosine. Okay, so what's the next use of your dot product is what we call the projection of vectors. So there are resources available which you can go and look at all the computer graphics, but then usually I don't want to use all these things. I want you to visualize it simply. Okay, in layman English, okay, layman English, it is, listen up, it is the shadow that you form when I put one vector above another vector. So what do I mean is graphically, okay, can you imagine a light source shining from the top? Can you imagine a light source shining from the top? So the light source is shining from the top onto the vector CH, right? It will cast a shadow down onto CA. Where is the shadow? CP, right? Make sense? So in simple English, projection is actually the shadow formed when I project one vector onto another vector. Can you understand? So always imagine a light source above. So far so good? So far so good? Let's try again. Look at the second diagram now. I want you to project HC. Just now I asked you to project CH onto CA, and you tell me the result is C. Okay? What if I want you to project HC? Okay, this way now. HC onto CA. Where is the vector? Where is the shadow? It's still down here, right? Is my projection CP or PC? PC. It all follows the direction that it starts from. So if I say that I want you to project HC, so I start from H. Okay, start from H. The projected vector will also start from this direction. Can I understand? Anyone lost? Okay, so look at the two subsequent diagrams that I have for you. Can you accept the projected vector CP and PC on your own? Okay, we play around with the direction. sometimes is this direction projected onto this direction, this direction projected onto this direction. Okay, but bottom line is the rule to remember is always remember the upstairs. Who is on top? That will decide the eventual direction. Okay, don't get distracted by the vector at the bottom. Look at the vector on the top, whether it's shooting out from the base or shooting out from the air. That will decide where is the eventual projection. Can? Anybody confused? Can understand? Okay, so I have gone through with you how to look at projection pictorially. So now I want to go through with you how to actually activate the formula for your projection. Okay, the formula that you must know is these two formulas. Can you please highlight? Okay, one is the projection, the other one is the length of projection. Okay, one is the projection, the other one is the length of projection. Okay, so highlight this thing. Okay, I will run through the proof with you using this diagram. Assuming theta is acute, as what you see in this picture, okay, in this diagram, I want you to activate your trigo to help me. Okay, what is cosine theta? Cosine theta is which length over which length? Which length over which length? HP? No, CP. Over CH, right? Make sense? Make sense? Anyone lost so far? So what actually is CP, length? If I play around with it, it's CH, magnitude, multiplied by cosine theta, right? Agree? So far so good? Okay, so remember this thing. I want you to look at the next section now. How do you actually find cosine theta? What actually is cosine theta? Based on this diagram. You have learned your dot product. What is cosine theta? Who dot who? If I'm interested in this angle, who dot who? Is CH dot with CA, right? CH dot is CA. So isn't it just CH dot with A? So let's look at this diagram now. Okay? So what I'm playing now is CH is actually equivalent to this based on your dot product. Is H dot with A divided by magnitude H divided by magnitude A. Can follow so far? Can follow so far? So this is via dot product. Then what you're going to see is the magnitude H will cancel off mathematically, and you're left with H dot A over magnitude A, which is actually H dot A hat, because I combine vector A divided by its magnitude is actually the unit vector. So this is the formula for the length of your projection is H dot with A hat. Can follow? Okay, the proof is for you to understand it easily rather than for you to learn how to prove. Usually, they will not ask you to prove in the exams, but it's good to understand because many students have problem memorizing formulas. Okay, so if this is the length of CP, what is the vector CP? The vector will be H dot A hat multiplied by A hat. Magnitude multiplied by the number of times of the unit vector. Okay, this is from your chapter 1. How we find a vector of certain length in a certain direction. So CP is in the direction of CA. And then I know the length of CP is the length of your projection. I want the vector, I multiply by the unit vector of A. So that's how these two formulas come about. Okay, so if you're absolutely blur already, you need to revise a bit on your chapter 1, how we find a vector in a certain direction of a certain length. Okay, to be more specific, let me point you to the example, then you'll be clearer. It is example number 5 of your chapter 1. Okay, the theory that you're using is example 5, chapter 1. Okay, I will not prove the obtuse case for you because it's almost the same. So bear in mind, you need to know the two formulas. Okay, projection formula, length of projection formula, that I must know. Second thing, okay, this scroll is super important. You will see this word appearing in many of your chapters, in particular vectors and complex numbers. So in vectors, they will ask you, give me the geometrical interpretation of h dot a hat. So you must actually recall, this is actually the length of projection of h onto a. Or h dot a is the length of CP onto the right angle triangle CHP. So how you want to answer this question? Some students prefer to use words. Some people don't know how to explain in words. They draw a diagram. So give me a diagram. Which diagram is this diagram? Okay, they actually draw this. This one. They draw this. Okay, they draw a diagram like that, and then tell me what actually is your h dot a. So in simple English, what is your geometrical interpretation? The meaning of geometrical interpretation is what is the physical phenomenon that's happening here. Can? Okay, so know the formula, know the geometrical interpretation that will be coming up. You'll see more of these things in your chapter 3. Okay, so the next one is actually a little bit of physics. Okay, the perpendicular components of a vector. So actually, if you actually from the secondary school, you can actually this is what you call the resolving of your forces. Okay, so CH, this one can be resolved into the horizontal component as well as the vertical component. That's how you resolve your forces previously. Okay, so whether you take physics now or don't take physics now, this is actually your secondary school skills. So nothing really fantastic, just that we put it into vectors theory. So CH is actually CP plus PH. Nothing really difficult. Okay, your resolving of forces is actually your addition or subtraction of your vectors. Okay, so let's try one example. Numerically, how to do. Okay, so what you have to do now in example 5 is find the projection of one vector and find the length. Find the projection and the length of projection of one vector onto the other vector. So when you have a question like that, please read carefully. Who projected onto who? Don't do the wrong way. Okay, I want you to project this onto the other one. Okay, so who is the upstairs, who is the downstairs? Please identify properly. Okay, so simple thing. Please look at the right column again. I will always tell students, please draw. The moment you draw, things becomes very clear. So I want to project 1 minus 1 onto the other vector. So physically or diagrammatically, which is your vector that you're interested in? This is the shadow. Okay, going in this direction. Okay, I need to find that vector. I need to find the length. How to do it? Just whack your formula. Projection of formula is activation of your h dot a hat. So if this is h, this is a, pump in the formula, finish. Okay, so if you know the formula, it's just whole chunk of numerical mathematical processes. And then of course that comes with the prerequisite. You better know how to do the dot product numerically. Okay, how to do dot product numerically one more time is you multiply across the rows. Add to the second row, multiply, add to the third row. Okay, so if you can do it on your own rather than copying, please do so. Okay, when you're actually copying all these things, right? I want you to understand I'm actually activating a lot of properties that's happening inside here. Okay, your property says that these two things can take out from the dot product, it doesn't matter. Okay, your commutative law works under dot product. So these two, 1 over square root 21 can come out together. And then, this is a dot product. This 1 minus 1, 1, dot with 4 minus 1, 2. Multiply to 4, 1, 2. This is a multiplication process, not a dot process. So, this is dot process, that is multiplication process. Okay, then eventually you end up with this as your vector. Simplify, you have your numerical projection of a vector onto another vector. Okay, that's finding projection. What if I want the length? What if I want the length? Same thing. Use the formula one more time. What's the formula to use? Magnitude of h dot a hat. So we are using this formula now. Okay, then you go through numerically. This is the answer. So far so good. Any questions? Anything you want to clarify? Anything not sure? Okay, please know your projection well. Please remember the formulas well. Okay, the earlier you commit to memory, the easier it is for you subsequently. Because next chapter I'll introduce you to another formula that looks absolutely the same. Okay, instead of the dot, I put a cross there. It's another new formula. That means totally different stuff. Can? Okay, so alternatively, you learn in chapter 1, right, how to find the magnitude of a vector. I can always, okay, I already found the vector itself. What's so difficult finding the magnitude directly? So I can always use your theory or your knowledge from chapter 1 to find the length of projection immediately. Okay, so this is your option. Example 6, important example for CT1. Listen again. Example 6 is an important example for CT1. But it is too easy for your A levels. Understand? Okay? As I said, CT1 we cannot test you anything fantastic yet. But we need to make sure you have the basic foundation. So, this example, possible to appear in your CT1, possible to appear in your CT2, but impossible in your A levels. Okay? So we're going to put a few of your theories or a few of your concepts together now in one example. So this time now I give you 3 points, ABC. I give you the 3 position vectors. Part 1, division again. Projection of BA onto BC. So I need to project one vector onto another vector. Okay? But this time round, I need to find what is BA first. I need to find what is BC. And then you also need to pinpoint who is the upstairs, who is the downstairs. So it's a good practice. Okay, just follow the column on the right. Okay, it's a good practice to write down in this way in your exams. Okay, rather than look at all the IJK, it's very irritating. You look at this, it's easy to see. You won't make many careless mistakes along the way. Okay, so understand, I need projection of BA onto BC. I must find vector BA first. I must find vector BC. So via your, we call that vectors addition, vector subtraction, you find BA onto BC. What's the next move? Activate your formula. Okay, so we are using this formula one more time. BA dot BC divided by its magnitude. Okay, so it's a rehash of your previous example. Okay, it's the same old thing. Activate your dot product, activate your properties, you end up with the projection of BA onto BC. Okay, so other than knowing how to find it numerically, please also understand where does it or what, how does it look like diagrammatically. Your projection of BA onto BC is actually BA prime. It's important that you know that it is BA prime. Any questions so far? Can I understand? Projection of BA onto BC is actually BA prime based on the diagram that I have on the screen right now. And next, in part 2, they ask you for the components of BA that is perpendicular to BC. Okay, diagrammatically, the components of BA that is perpendicular to BC. Okay, you need to remember your resolving of forces. Okay, so imagine this one. Okay, I draw it down here. If I were to resolve, which is the one that I'm interested in? This one, right? I'm interested in this one. Make sense? The component that is perpendicular to BC. Okay? So now what I want you to look is this vector, okay, the one that I draw in bold, parallel to A prime A. Parallel? So it's as good as asking you to give me the vector A prime A. Can you understand? So that's what's happening in your next solution. I'm actually trying to find A prime A, and how to do this is actually your vectors addition. A prime A comes from BA minus BA prime. Okay, A prime A comes from BA minus BA prime. So why do I choose to use BA and BA prime? Because I know what's BA, I know what's BA prime. I don't want to introduce the O to confuse yourself. Okay, so if you tell me I want to use A prime A to be equals to OA minus OA prime, can or not? Can, just that it involves more work. So rather than you use O, I can use B directly. Take reference from BA minus BA prime. You get your answer quicker than you use OA and OA prime. So far so good? Last part. Same thing, please read the question. Question asks you to find the least distance from point A to the line passing through BC. Okay, least distance from point A to the line passing through BC. So look at the original diagram that we have. Where is the least distance from point A to the line passing through BC? This is point A. This is the line passing through BC. Where is the shortest distance? Agreed? It's AA prime. Did you find what is AA prime? Can I find the magnitude? That's the length. Finish. Okay, if I can find what is AA prime, it's just a matter of you giving me the magnitude of A prime, and that will be the least distance. Okay, so bear in mind, how I handle this question very quickly and efficiently is because I have a diagram to play with. If you want to do everything without a diagram, it's going to be quite difficult, unless the power of imagination is very strong. You can view everything in the gray, in the sky, go ahead. If not, draw a diagram. Can? Okay, so congratulations. You actually have completed your chapter 2. But, okay, I want you to write something in your idea box. This idea box seldom used, but in this chapter, this becomes very critical. Okay, can you please write down the 3 key uses for your dot product? Before you write down, can you think through? Anyone can tell me what are the 3 key usages of your dot product? Number 1, if the question asks for angle, okay, angle of anything in vectors, confirm it is a dot product question. And so the first use of your dot product is always number 1, find angle. The moment you see find angle, find this angle, find that angle, always activate dot product. Okay? Second thing, what's the second use of your dot product? Find projection. The moment you see projection of this, projection of that, confirm it's dot product again. Okay? Why I keep asking you to do this is because understand your vectors question is an application question. These things must pop up in your brain when you read a question. So angle question, dot product. Projection question, dot product. Third one, if I ever ask you to show that 2 vectors are perpendicular, also dot product. Why so special? What's the phenomenon of perpendicular? 90 degree, right? What is cosine 90? 0. So if I ask you to show that they are perpendicular, how? If the dot product equals 0, confirm perpendicular. Okay? If the dot product of any 2 vectors is 0, 100% the 2 vectors are perpendicular. So these